What we're going to talk about today is a hypothesis test for the difference between two means, and this is going to be paired samples. And if you look at the first problem, it says a sample of 8 automobiles were run to determine their mileage in miles per gallon. Then each car was given a tune-up and run again to measure the mileage a second time. And you can tell from looking at this that this is a match pair because I've got 8 autos, and it's before tune-up and after tune-up and their mileage. The sample mean mileage was higher after tune-up, and we want to determine how strong the evidence is that the population mean would be higher after tune-up. They're paired samples because each value before tune-up is paired with the value from the same car after tune-up. When we have paired samples, the pairs are called matched pairs. By computing the difference between the values in each matched pair, we construct a sample of differences. And if you look at what they've done here, they've subtracted it, and clearly they have done after minus before. And if we denote the population mean before tune-up by mu1 and the population mean after tune-up by mu2, we're interested in the difference. Because these are paired samples, the population mean of the difference, and I like how your textbooks does mu of d, because you know you're talking about the difference. It's the same as mu1 minus mu2. Therefore, performing a hypothesis test on mu of d is the same as performing a hypothesis test on the difference of the population means. And what we're going to do with this, what this turns into is a one sample. It turns into a one sample t-test. And D bar is the sample mean of the differences. And like I said, you can use X bar, but they're using D because it's the differences. S of D is the sample standard deviation. Mu of D is the population mean difference for the matched pairs. And all we're going to worry about is the differences. And where it turns into a one sample t-test, you don't have to do independent because it's not independent. All you need to do is your SRS, and then you need the normal condition, but only on the differences. Okay, so only the differences. And if you look at this, the math behind it, I put this paper in here just so you could look at it if you needed to, but this is the same t statistic that we used with the one sample t, except they're using the differences, the mean of the differences and the standard deviation of the differences. Now here's our question, and they're giving me the hard part about these questions, and you'll see that on Alex. The hard part is finding your H1. And notice this time they're giving us H1, and this has a low significance level, so I'm going to be careful on that. It's going to require a lot of evidence. And notice the only thing it gives me is the difference, because that's all I need. I don't need the other material. So here's what I'm going to do. When I check my conditions, I'm going to do SRS check, and I'm going to graph the differences. I didn't put my calculator up. But do a box plot of the differences. And what you're going to do, you know, it's always going to be okay. When I graph it, I'm going to do this. And I'm going to say no, and this is only the differences. No outliers or strong skewness. Normal check. And H of O on these differences is most of the time going to be there is no difference. Mu of D equals 0. Sometimes it can have a different number. You'll see that on Alex, but mostly it's going to be 0. H1 is what's tricky. And in this H1, it gives it to us mu of D is greater than 0. So I'm going to go to the calculator, and I'm going to do a t-test. I'm doing one sample t-test. I'm going to input my data. My mu naught is 0. My list is L1. Don't mess with frequency. My mu is greater than mu naught. That's my H1. And I'm going to calculate it. And here's what I get. I did a t-test. So here's my screenshot. And I did mu is greater than 0. My T is way out there. So notice that T is way out there. It's 9.143. And when you look at that p-value, I'm going to put it up here. It's scientific notation, 1.925, more numbers, and e -5. That's very small. You need to move that decimal over 5 places to the left. So I need to add 4 zeros, 0.1234419. Okay, and if you look at that number, that is approximately 0. If we took it to 4 decimals, it would be 0. So I'm going to put for my p-value, I'm going to put approximately 0 for my p-value. And here's what I'm going to say. I'm going to say, and notice that my p-value is very low. So since my p-value is low, HO is going to go. So I'm going to say, since my p-value, I like to put approximately 0, is less than alpha equals 0.01, we will reject HO. We have enough evidence to conclude the true mean difference is greater than 0. In other words, you get better gas mileage once you do a tune-up. For interpreting the p-value, I'm going to say if HO is true, there is an approximately 0 chance of a test statistic as extreme or more extreme than ours. And ours is T equals 9.143. And what I want to do, the next 2 questions we're not going to do, but I just want to show you how to set them up. I think everyone's fine on the conditions and the problems and so forth, but I want you to look at this problem. It says, when you look at it, it says, following are the annual amounts of rainfall in inches in 6 randomly chosen cities for 2 consecutive years. Can you conclude that the mean rainfall was greater in year 2 than in year 1 at the alpha equals 0.05 level? So here's what I want to know. Now you got to be careful with this H1. So here's what I'm going to do. Clearly I need the differences. So what I want you to do is pause the video and get your differences. And I'm going to do year 2 minus year 1. All right, so I'm going to pause too and get my differences. And then we're going to set the problem up, but not actually do the whole thing. When you look at this one, I've done all the differences. We're not going to do the problem, but when you do your conditions, the only thing that you worry about are those differences. So that's the only thing I worry about. I do my conditions based off of them. The year 2, year 1 could be gone. When you do your HO and your H1, you want to be careful. Most of the time, HO is mu of D is 0. Not always, but most of the time. And you don't have to say mu of D. You could just say mu. I like that it says D because that tells us that I'm doing the differences. When you look at H1, it says, can you conclude that the mean rainfall was greater in year 2 than in year 1? That does not always mean a greater than sign. So this is what I do. Look for a year where it was greater in year 2 than in year 1. Like our first one, it was greater in 2 than in 1. Like our 6th one, it was greater in 2 than in 1. Every time it's greater in 2 than in 1, if you look at the difference is positive. Okay, so the difference is positive every time. And a positive difference is greater than 0. So my H1 would be mu of D is greater than 0. So that's how you're going to set that up. And that will help you on the Alex assignment too. The last one. When you look at this one, we're going to do the same thing. I want you to pause the video and set this up. And then we're just going to set it up. We're not going to actually do the problem. When you look at this one, I've done the differences. Remember from before, it doesn't matter about rear and front. I only want the differences. So I type that in on my calculator. I do my conditions off of that. And here's what it says. So we've done our conditions. It says, can you conclude that the mean time for the rear brake pads to wear out is longer than the mean time for the front? So the same thing. HO is there is no difference. And H1, look for one where the rear brake pads was longer than the front, like the first one. The rear was longer than the front. It's a positive answer. And if you look, they're always a positive answer. All right, so my H1 is going to be mu of D is greater than 0. And that's how you do the matched pairs. They're not independent t-tests. They're just a one sample t.